Hello Year 11 Mathematics Advanced students. Today we're continuing on with the topic of functions, and we're learning about polynomial functions. So a polynomial is a function defined for all real x involving all powers of x in the form of px equals an x to the power of n plus an minus 1 to xn to x to the power of n minus 1 plus a n minus 2 x n to the power of n minus 2 all the way to a2 x squared plus a1 x to the power of 1 plus a0, where n is a positive integer or 0 and a0, 1, 2, etc. to an are real numbers. So we generally write polynomials from the highest power down to the lowest. For example, px equals x squared minus 5x plus 1. So we have already studied some polynomial functions, as linear, quadratic, and cubic functions are all polynomials. So let's have a little look at some polynomial terminology. So for our polynomial here, we have that it is called a polynomial expression, where px has degree of n, so whatever the power of n is the degree, so where our n is the highest power of x. So if we had the highest power being x cubed, then our degree would be 3. We have an minus 1, an minus 2, all the way down to a0. These are called the coefficients. So they are the values in front of our x's or our pronumeral. Our an x to the power of n is called the leading term. So the term that has the highest degree will be the term that comes first and has the leading coefficient, so which is our an, which is our leading coefficient. So it's the first coefficient of the whole polynomial. Our a0 is our constant term because it has no x attached to it. And if an equals 1, so our leading coefficient equals 1, px is called a monic polynomial. So let's have a look at some examples. So question 1, we want to know which of the following are polynomial expressions. So if we look at a, we need to work out whether it is or it isn't a polynomial expression. So a is a polynomial expression, so it is yes to being a polynomial because it has a 4 minus x plus 3x squared. So it has, it's just been rewritten incorrectly. A polynomial should be written the highest power first, so it should be rewritten as 3x squared plus x minus 4, which is a polynomial. B, 3x to the power of 4 minus x squared plus 5x minus 1 is a polynomial, yes, because we have it there and it fits the brief. However, xc, which is x squared minus 3x plus x to the power of negative 1, is not a polynomial, so that's a no. This is because it has a term of x to the power of negative 1 that is not a positive integer power of x. So our powers of x needs to be positive. For example 2, we have px equals x to the power of 6 minus 2x to the power of 4 plus 3x to the power of 3 plus x squared minus 7x minus 2. So we want to find the degree of px. So if we scroll up, to find our degree, it's n, where n is the highest power of x. So our highest power of x is 6. So our degree of our polynomial equals 6. We want to know, is the polynomial monic? So if an equals 1, px is a monic polynomial. So this is where an is our coefficient of our first term. So again, we're looking at our first term and it has a 1 in front of it, or nothing in front of it, meaning it has a 1. So that means yes, our polynomial is monic. Okay, C, we want to state the leading term. So our leading term is the term that's at the front. So again, this is our x to the power of 6. We then want to state what the constant term is. So this is the term that has no x value. So our constant term is our -3 back here. Okay, and then we want to find the coefficient of x to the power of 4. So this is going to be the value that is in front of x to the power of 4. So it is going to be our -2 is our coefficient. So we can have polynomial equations. So this is where px equals 0. So it's a polynomial equation of degree n. So the values of x that satisfy the equation are called the roots of the equation, or the zeros of the polynomial px. So we want to, in our example, we want to find the zeros of the polynomial px equals x squared minus 5x. So we're going to let this equal 0. So we're going to go px equals 0. So we'll have x squared minus 5x equals 0. We can take out a common factor of x. So we'll have x bracket x minus 5 equals 0. So therefore, our x values are 0 and 5. So therefore, our roots are x equals 0 and 5. Oh, sorry, our zeros, not our roots. Apologies. Helps if I read the question properly, doesn't it? Okay, so then for example 4, we want to show that the polynomial px equals x squared minus x plus 4 has no real zeros. So we want to solve px equals 0. So we'll have x squared minus x plus 4 equals 0. So because we want no real zeros over here, we should use our handy friend, the discriminant, which is what we did in a past exercise, which is triangle equals b squared minus 4ac. And because it's no real zeros, we want our discriminant to be less than 0. So this is what we're trying to find. So we're going to sub our discriminant in. So b squared minus 4ac. We'll just state what our a, b, c are over on the side. So a equals 1, b equals -1, and c equals 4. So we'll have triangle, or our discriminant equals b squared, so -1 squared, minus 4 times 1, which is our a, times our c, which is 4. So discriminant equals 1 minus 4 times 1 times 4 is 16, which equals -15, which is less than 0. So because our discriminant, therefore discriminant is less than 0, so the polynomial has no real roots. Okay. Next, we move on to graphing polynomials. So to graph polynomials, we first need to find the intercepts. So for the polynomial px equals x to the power of 4 plus 2x cubed minus 3x squared, we want to write the polynomial as a product of its factors. So this is exactly the same as writing the polynomial equal to 0 sort of thing. So we're going to say px equals, we're just factorizing it. So we're going to take out a common factor of x squared and now that we've done that, we can factorize our brackets to be a double bracket. So it will be x plus 3x minus 1. And so we have now write the polynomial as a product of its factors that way. So next we want to sketch the graph of the polynomial. So we need to find our x-intercepts. So we're going to let y equal 0, but we're going to use our polynomial here. We're going to use that straight away and let y equal 0. So we've got 0 equals x squared bracket x plus 3 x minus 1. And the reason for this is we've already factorized it. So therefore we can write that our x equals 0. It equals negative 3 and positive 1. And then we need to find our y-intercepts. So we let x equal 0. So it will be y equals 0 squared bracket 0 plus 3 bracket 0 minus 1, which will just equal 0. So let's plot them on our graph. So our 0 is here. 1, 2, 3, 4. So our 1 is going to be there. 1, 2, 3, 4. Our minus 3. And then we don't really need these going up, but I'll just do the dashes here, meaning that each one is a 1. And we're just sketching it, so it doesn't have to be absolutely perfect in terms of having every number on, etc. So let's do our x-intercepts and our y-intercepts in blue. Now, we don't know whether the graph of our polynomial starts up here or if it starts down here. So what we're going to have to do is we're going to have to test in between each thing. So we're going to test when x is less than negative 3. So we're going to let x equal negative 4, and we're going to sub that in. So p of negative 4, equals, sub that into our equation. So negative 4 squared bracket negative 4 plus 3 bracket negative 4 minus 1 gives us 80, which is greater than 0. So that means our polynomial is going to start up here. Then we're going to test in between minus 3 and 0. So test between minus 3 and 0. So let's test x equals minus 1. So sub minus 1 into our equation. So when we sub minus 1 into our equation, we get negative 4. So that's less than 0. So that means between 3 and 0, we're going to go like this. We go below the x-axis. So then we're going to test between 0 and 1. So we're going to have to sub in x equals 0.5 into there. So we get a negative, again, we get a negative 0.4 ... So that means it's going to go below the stay below the axis. Like so. And then we just need to test what happens after 1. So we test x is greater than, that's not very good, greater than sign, greater than 1. So let's test x equals 2. So we sub that into our equation. And so when we sub that in, we get 20, which is greater than 0. So that was less than 0. So we go up above the axis. And so that is roughly what our polynomial looks like. So now we just need to write our polynomial on our graph. Px equals x to the power of 4 minus 2x cubed minus 3x squared. And that is our polynomial sketched. So if you're following through the Maths in Focus textbooks, if you are in advanced, you will do exercise 3.13. And if you're in extension, you would do and following the extension textbook exercise 4.14. Have a lovely day.